Hello students, welcome back. In the previous class of class 11 science, we have discussed about few basic topics related to motion in a straight line. Now from the same chapter, today we will be discussing about time displacement graph. There are different types of graph. First one which we are going to discuss is time displacement graph. Now from the time displacement graph, what we can find is we can find the velocity. So this is a graph. On the x-axis we are drawing the time axis. Unit of time is second. On the y-axis is the displacement axis, and displacement will be in terms of meter. So the values are given as such. When time is 0, displacement is 0. So the first point is over here. When time is 1, displacement is 20. When time is 1, displacement is 20. So second point is here. When time is 2, displacement is 40. So displacement 40 is, around here. So when time is 2, displacement is 40. Then when time is 3, the displacement is 60. So when time is 3, the displacement is 60, somewhere around here. And when time is 4 second, displacement is 80 second. So around here. So now at last what we do is we join all these dots. When we join this dot, what we get is we get a straight line which shows the velocity of this object which is moving in such a way. Now from this graph, how do we calculate velocity? Is we draw a slope. For that, what we do is we take 2 points and we draw a triangle. Okay, we draw a triangle taking 2 points. Let this point be B, over here be C, and this be A. Now when we draw this when we get a triangle, from this triangle we can actually find the velocity of this particular graph. Now we draw a straight line towards this y-axis. This point over here will be your S2. Now from this point A also, we draw a dotted line towards over here. This will be your S1. Similarly, B will draw a downward dotted line. This has to touch over here exactly. This is your T2, and this point downward will be T1. Now, from this type of graph also, we can actually find the nature of velocity, whether it is uniform or non-uniform. So how do we find that is, okay, I'll just show you over here. Now velocity, the formula of velocity is displacement over time. So for this one, displacement is 0, time is 0. 0 divided by 0 is 0. Second one, displacement is 20, time is 1. The 20 divided by 1 will be 20. Next one, 40 and 2. 40 divided by 2 will be 20. 60 divided by 3 is again 20. 80 divided by 4 is again 20. So what we can see over here is the velocity is constant. The velocity what we have calculated is constant. It shows that the velocity over here is uniform. Okay, so this way we can find the type of velocity. Now, how do we calculate from the graph? From the graph, velocity is equals to, okay, S2 minus S1 divided by T2 minus T1. So your S2 from the graph is 60. S1 from the graph is 20 divided by T2 is 3 minus T1 is 1. So when we do this, we can also find the velocity. So 60 minus 20 will be 40. 3 minus 1 will be 2. So ultimately how much we get is 2 meter per second. So in both the way, what we have found is we have found the velocity as 20 meter per second. Now this is how we find the slope from any type of a graph. This is displacement time graph. From here we can find velocity. Now I'll show you different types of graph in order to understand this better. First one is, in the same graph, y-axis is displacement, x is time. In the same graph, I have plotted two graphs. The values are not written, just for a reference point. I have drawn line A and line B. Now, what we can see is line OA is much higher than line OB. So, clearly from this graph, the slope of OA is greater than the slope of OB. Okay. Then when the slope is greater, the velocity of an object traveling through the path OA is greater than the velocity of the object traveling through the path OB. It means greater the slope, greater will be the velocity. This is from the first graph. Second graph, in this graph what you can see is time initially is 0, time slowly increases, but the displacement of the object is still at same. Suppose this is at 30 meter. So the displacement is still at 30 meter. It means if you draw a slope, the slope will be 0. Slope 0 means there is no change in the velocity. Over here, velocity is 0. The object is not moving at all. It is fixed at one single point. Okay. Now the second type of graph over here. If a graph line makes an angle greater than 90 degrees with the x-axis, then it means that the object is returning back towards the reference point. Over here what you can see is an object is moving from point A. The slope is this kind of a slope. That means the slope is a negative slope. It reaches over here. It makes angle which is greater than 90 degrees. This angle is greater than 90 degree. And slowly the displacement is increasing in the negative axis. If a graph looks like this, it means the object is returning back towards the reference point. Now suppose when we find the velocity of this type of a graph. So we consider this triangle over here, triangle O or AOB as a slope. Okay, we consider this as a slope. So now this point over here will be your, this point over here will be your S2. This point will be S1. This point will be your T2. And this point again will be your T1. So S2 minus S1 divided by T2 minus T1. Okay, now S2 is 0 minus 20 divided by 10. Suppose this B at this point is 10 seconds. 10 minus T1 is 0. So when we do the calculation, we get minus 2 meter per second. So from this type of a graph, a slope like this, okay, not an increasing slope but a decreasing type of a slope, shows that the velocity of an object is negative. It is decreasing continuously, and it can be said that the velocity of an object is negative. So, or this negative sign of the velocity indicates that the object is moving in a reverse direction. That is, it is returning. Okay, object is returning from another point, from point A to the point B. So, object is returning back to the reference point. That is why the velocity will be negative. Okay, now in the third type of a graph. In the third type of a graph, what we can see over here is the slope continuously changes. The slope keeps on changing. if the time displacement graph of a moving object has several lines of different slopes, then it means that at times the velocity of the object changes. So from O to A, velocity is same, but it changes from this point A till it reaches point B. The velocity at this point OA and AB is different. Now again, velocity of BC is different to the velocity of point CD. So the object is starting from point A. The velocity keeps on changing at several points. Now if you look at this graph, the slope of OA is greater than the slope of AB. So when the slope becomes greater, I have told you velocity at this point OA is greater than the velocity at point AB. And at this point, the time is increasing from 6 seconds to 12 seconds, but the object is at 5 meters per second. It is not moving higher or not going down. So the velocity at this point is fixed. The velocity is not changing, or velocity is 0. Velocity is 0 means the object is not moving at all. The object is at that exact point where the displacement is 5 meters. Now from this point, when the graph starts decreasing, it means that the vehicle or the object is in reverse direction. If it decreases, then slope is negative. Slope negative means it is in reverse direction. And it is decreasing very fast because the slope is very high compared to at any other point. So the velocity is high, but in negative or in reverse direction. I'm just teaching you how to recognize the different types of graph. Now the fourth graph, again it is displacement time graph, but the slope is not a straight line, but it is a curved line. Now if it is a curved line, how do we find a velocity? To find a velocity, we can either find the instantaneous velocity. Instantaneous velocity means velocity at any point. Suppose for this point, what is the velocity? That is what we can find. Or any other exact point, we can find the velocity. But if you want to find the velocity of this whole line, that velocity will be known as average velocity. So how do we find the average velocity is? We draw a line over here. Okay, we draw a line over here. This point, let us consider it as Q. This point as P. Now let us draw a triangle. Okay, considering 2 points, we draw a triangle. This point is R. Okay, the value of this point on the y-axis will be S2. Value of this point on the y-axis will be S1. Again, the value of this point on the x will be T2. Value of this point will be T1. Now to find the slope of the line, the slope will be the velocity, will be S2 minus S1 divided by T2 minus T1. This is how we find the slope. So this slope will be known as your average velocity of this curve. This will be known as the average velocity of the curve. So I have shown you the different types of graph and different nature of graph, and how we can recognize whether the velocity is increasing, decreasing, or constant, or it is an average velocity. So by analyzing the graph, we can find all the different types of velocity. This is velocity time graph, displacement time graph, which gives us the velocity. In the next class, we will be discussing about time velocity graph and time acceleration graph as well. So this much for today. Thank you.